Hi, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss a topic called database trading. So let's get started into the topic database trading. So a single database server can only store and process a limited amount of data. If you find a way to horizontally scale your database, you can potentially store an unlimited amount of data. So database trading is simply splitting a large database into larger databases into smaller pieces we call shards. If you get lucky and attack more and more customers, the amount of data also increases over time. Now the data becomes a bottleneck. If too many users attempt to use the application, then to read or save data simultaneously, the application slows down, negatively affecting the user experience. So sharding not only allows you to store more data but also improves performance by reducing latency for each query. This is because you can now push down the query to each individual shard which has a smaller data set. There are three main reasons why should you be using sharding. First of all, it reduces time. By splitting a database into smaller data sets, it improves query performance as it needs to search through fewer rows compared to a monolithic database. Second, it can help to avoid total service outage. Most of the time, we are not only splitting data across different database servers, but we also configure replication. So, if one shard becomes unavailable, the data can be accessed and restored from another thing. Finally, a growing database consumes more computing resources and eventually reaches storage capacity. There are so many disks you can attach it to a single server. Therefore, sharding can solve this problem by scaling the database horizontally instead of vertically. Also, you can add shards at runtime without shutting down the application for maintenance. Now, let's see how the sharding works. A typical unsharded database stores data in multiple partitions or shards, columns and rows. So database sharding splits a single data set into multiple shards. Each shard contains unique rows of data which are stored separately and across multiple computers or the nodes. All the shards run on separate node but share the same schema or the design. The partition data chunks are called logical shards. The machine that stores the logical shard is also called a physical shard or database node. Keep in mind that a physical shard contains multiple logical shards that belong to the same table. Now, software developers would use a shard key to decide how to partition the dataset. A column in the dataset, such as the customer name, determines which rows of data group together to form a shard. Developers can choose a shard key from an existing column or create a new one. Database sharding operates on a shard-nothing architecture. Each physical shard operates independently and is unaware of other shards. Only the physical shards containing the data you request will process the data in parallel. Above the shard, we have another abstraction software layer that coordinates data storage and access across these multiple shards. For instance, some databases have automatic sharding features built in. In others, you as a software developer need to write sharding code to store or retrieve data from the correct shard. Now let's discuss the different approaches you can take to shard your database. One of the simplest method might be to use range-based sharding. The simplest method is range-based sharding, also it is known as dynamic sharding. This approach splits database rows based on sharding. For example, suppose if you decide to use a customer's name as sharding key, now let's say you want to create 3 shards. In the first shard, you would place all customer records if the customer name starts with a letter between A and I. For the second shard, you have to use the letters J through S, and so for the third one you have to use 3 to Z. Every time you write or to retrieve data from the database, your application of the database checks the first letter of the customer's name and places that record in the corresponding Depending on the data values, range-based sharding can result in the overloading of data on a single physical node. In our example, the first range from A to I might contain a large number, significantly more customers' names than the instance the third shard where names starting from T to Z. However, this method is easier to implement.